So we're going to move on to chapter 2. And chapter 2, we're looking at the transformation of functions. So ultimately, like, how do we move things around? So our first section, 2.1.1, chapter 2, topic 1, section 1, is going to have to do with nonlinear data. So if we go through and if we kind of talk about some of the functions that we already know. So when we started all this good stuff about, we need to be in our assigned seat, please. You need to be in your assigned seat, please. No, you need to be in there now, please. Thank you. So when we looked at functions, we started off with linear functions. So if we wanted to write a linear function like y equals mx plus b is an example of a linear function. So we need to talk about when we're looking at equations, how do we know if something is linear or not? So if we look at our x variable, what's technically our exponent on that x variable?
Is it 1?
It's 1. Yeah, we just don't write the little 1 up there, right? So anytime we have where our x is raised to that first power, we know that it's always going to be linear. Then we started spicing things up in life, and we got to this thing called the quadratic. So that standard form of a quadratic function is like y equals ax squared plus bx plus c. And we're good at factoring those now, aren't we? And when I look at an equation, guess how I know that it's always going to be a quadratic? Yeah, the exponent, right? What's my highest exponent? Whoops, I just erased it. My highest exponent is that 2. So because my x is squared, I know it's always going to be a quadratic. Isn't that pretty sweet? So today we're going to expand that a little bit, and we're going to look at exponentials. It's like I wish I could make those lines just a little bit thicker. So when it comes to us writing exponentials, we're going to write it as y equals a b raised to the x. So the crazy part with when it comes to exponentials, when we look at a graph, we'll always know we have an exponential function. What looks different about it? Yeah, absolutely. Yep. Your exponent is that variable. So anytime the variable is in the exponent, you know you have an exponential function. So we can put the variable is the exponent. So just trying to figure out what our a and our b and all that good stuff is. When you have an exponential function, your a is going to be, we refer to it either as the initial value or we call it the y-intercept. So once we get to looking at these, as soon as I look at that first number out front, I know where it's going to cross the y-axis.
So that's basically the plus b.
Say again.
So, and y equals mx plus b
Yep. Yeah.
That's the A is the
Yeah. Yep. And then our B, this is our, we call it the multiplier because we're multiplying. And this is going to tell me if it's either a growth or if it's a decay. We'll get into some more examples on that, but ultimately if that B is greater than 1, it's going to be a growth, and if it's less than 1, it's going to be a decay. So, because if you're multiplying something by half, if I multiply something by half, is it getting bigger or smaller? It's getting smaller every time, right? It's cutting it in half. All right. So you ready to look at one? So let's say we have y equals 4 times 3 to the x. So what family of function does it belong to?
exponential growth.
Yep, it's exponential, and we know it's exponential because our variable is in the exponent. Yep. We can either make a table and graph some points. So for poops and giggles, if we didn't know how to graph this, we could come up with some x's and y's. I want to throw a negative number out there. If I said x was -2, that would be what? 4 times 3 to the -2, right? Do we remember what to do with negative exponents? We don't like negative exponents, right? We want our exponents to be positive. So wherever it is, so like the 3 is like on the top in a sense, you're going to flip it. So this is the same thing as 4 times 1 over 3 squared. So what's I going to, so if we want to write these all as fractions, it'd be what, 4 over 1 times 1 over 9. How do you multiply fractions? Straight across. So that gives me 4/9. Okay. So that would be the point. X is -2, y is 4/9. You want to try -1? So 4 times 3 to the -1. If we write them as fractions, that would be 4 over 1 times, what's 3 to the -1 going to do? Is that 1/3? So that's going to equal 4/3. So that's the point, -1 4/3. Let's try a 0. See if we remember what happens with the 0. So we have what? 4 times 3 to the 0. What's anything raised to the 0 power? 1 or 0? It's 1. Yep. Remember back in the day when we were kind of just working on like some exponents, and if you had, we'll do variables. Like if you had x to the 5th divided by x squared, you guys remember how to simplify that? It's x to the 3rd, right? You're subtracting the exponents, right? So 5 minus 2 is 3. So if we simplify this, this would be x to the 3rd, right? Granted, you could write 5 x's on top, 3 x's on the bottom, or sorry, 2 x's on the bottom, right? 2 of those are going to cancel out and you're left with the 3, right? Yes?
And algebra 1, the whole, I think it's what we're doing now, when we flip and put 1 on the bottom so that the exponent's positive. So basically, if you put it on the exponent, you flip to the bottom, all you do is flip to the bottom and it becomes positive.
you could rewrite that as x to the 5th times x to the negative 2.
So it's not changing anything, it's just changing
Right. You're just, yep. Because then when you multiply exponents, you add them together. So what's 5 plus a negative 2? 3. So you're still at x to the 3rd. Yep. So now if we get a little creative, and let's say we had x to the 5th over x to the 5th. Okay. So technically we would be doing what to our exponents? Subtracting them. So we would get x to the 0. Okay. And if you have anything over itself, what's it going to equal? 1. Yep. So anything raised to the 0 power is always going to be 1, right? Because think about it, they would have been over each other. Right? So if we go back to our fancy little problem, 4 times 3 to the 0 is 4 times 1, which is going to give us 4. So that would be the point 0.04. Right? And then for poops and giggles, let's just do one more. Pick a number. 5. So you got to do this one for me. Yep. So 4 times 3 to the 5th.
And you don't have to flip it.
Nope. Right. Yep.
So then you just do
Yeah. Orders of operation, what do you have to do first, technically? Exponents, right? So you'd have to do 3 to the 5th and then times it by 4. Let me do this one in my head real quick.
3 times 4 3 times 3 is 5. 7 is 18 times 18 times 30 is.
If I did it correctly, I think I end up with 972. Is that what you got too in your head? Yes. Yep. So that's the 0.5972. Oof.
There's no pattern. It just gets.
Right, it is, yep.
Has to go to- oh,
Well, what kind of growth do you think this is? Do you think it's exponential growth or exponential
it's
decay?
definitely growth because you figure it's over 1.
Yeah, yep. And so it's growing by a factor of 3 every time. So it's going to get higher and higher and higher. So if we were to plot our cheesy little points, right? -2 and -2 and then 4/5. 4/5 is half-ish.
4/5 is something. That's
Right.
That's 1.
So somewhere like right in there-ish, right? And then the second point we had was -1 and 4/3. How much is 4/3? Like 1 1/3, right? 1.3-ish. So I'm going to be just over 1, right? 4 or 0.4. Can we plot 0.4? And then somebody picked 5, 907, way up there, right? Whoop. Right, that's all right. Oh, sometimes in life you just make your dots bigger or lines thicker, right? And it's going to keep going up that way. What's going to happen as it gets closer to the y-axis? What do you think? Or the x-axis? Yeah, you think it's ever going to cross it? Nope, it's never going to cross it, right? It's going to get close. Remember that asymptote when we learned those? Yeah. So when we look at our equation even, right, we already kind of figured a little bit of this out. We knew just by looking at the equation, where was it going to cross? It was going to cross at 4. Well, look at that. It crossed at 4. Okay. The 3 tells us it's a growth, so it means it's going to start going up quite quickly. Yeah. All right. You guys ready to work on some Desmos? You guys know how to input stuff into Desmos? Like graphs? I think we've done that enough times throughout your high school career to where you can go, right? Or if you have a graphing calculator. So on your guys' like assignment for today, a lot of it is the 2-4 has to do with you guys kind of like coming up with a graph. Think of those step functions again. Remember like the number of buses? Some of the other ones are putting things into the graphing calculator. So for like 2-5, A is putting in y equals x minus 2 squared. B is y equals x squared plus 2. C is y equals x plus 3 squared. And D is like y equals negative x squared plus 5. So they want you guys to kind of like compare and contrast to see if you can figure out, like ultimately, if this whole entire thing is squared versus just x being squared, how does that affect the graph? How does like that minus 2 versus that plus 3, how do those two differ from each other? Like how does this x squared plus 2 and like that positive x squared and that negative x squared, what does that do to the function? So on Desmos, you can actually put in all 4 of those functions, right? And they'll all show up like on one graph. But I would kind of play around with it. And if anything, like put these two in together so you can sit there and see how those two differ. Put these two in to see what that negative does. Guess what the negative does? Extra credit if you can tell me right now. And then when you compare these two, like see what the difference between that negative 2 and that positive 3 is going to do to the function. Sound like a plan? Yes. Yep. Yep.